Okay, so let's take a look at a few diploma questions that have to do with electrochem. So the first one is just understanding your theory between voltaic and electrolytic. So let's start going through that. So it says, which row identifies one characteristic of a voltaic cell and one characteristic of an electrolytic cell? So if we look at A, right away we know that's wrong because it's saying the E of the cell is less than 0. So that would mean that it would be an electrolytic cell because voltaic cells have positive cell potential. And then this part is also wrong because electrolytic cells are non-spontaneous. B, looking at that, says converts chemical energy to electrical energy. So for voltaic cells, that's true. For electrolytic, move anions towards the cathode. It doesn't matter which type of cell we have, anions always move towards the anode. C, moves electrons towards the anode. That's not going to be right. Electrons always move to the cathode. It doesn't matter which cell we have. And this part here reduces the strongest oxidizing agent at the anode. The anode undergoes oxidation, which needs a reducing agent. So that one's also not true. And then the last one requires a salt bridge. That's true for both cells. And the for electrolytic requires an external power source. That is also true because those reactions are non-spontaneous. So they need some electricity to make that reaction happen. Our next one, this one gets a little bit confusing. It's not a common substance that we see, this silver sulfate. So this is, if you take a look at your data booklet, it's not in solution. And if it was, sulfur's ion doesn't appear. It doesn't actually decompose into its ions. So I shouldn't say decompose. I should say dissociate. So here, when we're looking at the half reaction that the hydroxide ion undergoes, well, we are going to look at our data booklet and figure that out, but we want to list what we have present. So you have that Ag2S. This does appear on your data booklet as an OA on page 7. Then you would also have Na positive, right, because of this part here, and that is also an OA. And you have OH negative, which is a Ra. And then lastly, you have water, which is both OA and an Ra. So now looking at this part, being that OH negative is an Ra. Ras undergo oxidation. So we would have to flip this half reaction, and the one that shows that is A. And then lastly, this question here is to do with spontaneity. So saying which of the following metals will react spontaneously as a reducing agent with silver iodide, but not with silver sulfide. So looking at placement, if you have silver iodide, so that one, now I can't seem to find it. Silver iodide, you probably already see it. Okay, well, silver iodide, this one, and oh, there we go. It is right there. So if you're going to react spontaneously, you would want the metals to be below. And if it's not going to react with silver sulfate, the metals that's listed would be above. So when we start to take a look at a few of them, first of choice, when we look at the mercury and copper, those are both higher up on the right-hand side of the table. So that wouldn't react with either of them because for all of these, your Ra would be higher than your OA, which means you're non-spontaneous. If I look at B, chromium is down here. Chromium then means that would work for both. And same thing with aluminum. It's going to work for both because both of these are OAs and they will be higher than your RAs. So those would be spontaneous. And we're looking for something that will not work with silver sulfide. So not that one. C has nickel and cobalt. So nickel and cobalt are here. They definitely will be non-spontaneous with with silver iodide. But because they are higher than your OA of silver sulfide, it's not going to work. So that one will be our answer. And we can double check the last one. The last one also has ones that would end up working for both. So that also will not be a choice. As always, I hope you found this helpful. If you did, please subscribe. And if there's any other video I could do for you, just let me know. Tomorrow I'll start making some videos for some more organic chemistry diploma questions. Thanks for watching.